All right, we're continuing transformations of quadratic functions, and we are up to example 3. Example 3, we are writing a transformed quadratic function. So now we're going to be writing a new function. Let the graph of g be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. So again, we're transforming the parent function to a new location. Write a rule for g and identify the vertex. All right, so we know if it says there is a vertical stretch by a factor of 2 and a reflection across the x-axis, we can start with that. So we're going to have a reflection and we're going to have a vertical stretch. All right, so both of those affect the value of a. All right, so the reflection makes a negative, and this one says a vertical stretch by a factor of 2. So we know that a is going to be negative 2. So we can say a All right, how do we know? This is a vertical stretch, so we know that a just stays as a. Remember, if it's a horizontal, it would be 1 over a, but this one is a vertical stretch and a reflection across the x-axis. So we know that a is going to be negative 2. What else do we know? It says it is followed by a translation 3 units down. All right, so 3 units down, that would be our k value. So a translation 3 down, that means k equals negative 3. If it went up, it'd be positive 3. Going down means k is negative 3. All right, so that's all the transformations we have. So we're going to do a transformation from f of x equals x squared. So it says write a rule for g and identify the vertex. All right, so what is g of x going to be? It's going to look like a times x minus h squared plus k. All right, so we identified a as negative 2. So we're going to say g of x equals negative 2. And we do not have an h. There's no h, so we can say that is 0. And k is negative 3. All right, so we could leave it like this, or we could simplify it a little bit. When there's a 0 here, we don't really need that. So we can say negative 2 times x squared minus 3. And x squared is really just x squared. So negative 2x squared minus 3 would be your g of x. So that's how you would take the information given and write a rule, write a transformed function. And from this function, you can also determine the vertex. So your vertex would be 0, negative 3. Example 4, writing a transformed quadratic function. Let the graph of g be a translation 3 units right and 2 units up, followed by reflection in the y-axis of the graph f of x equals x squared minus 5x. Write a rule for g. So you can see this time we're not looking at the parent function, we're transforming a different function. So it says, let the graph be translation 3 units right and 2 units up, then followed by a reflection of the y-axis. So let's do this in 2 steps. So let's start with only looking at the first part. We're going to translate 3 units right and 2 units up. So what does that look like? let's call it a different function. Let's not go straight to g. So let's say h of x equals, we're going to take the function of f, and we're going to do 3 units right. So it's going to be minus 3, and then 2 units up, plus 2. All right, so that's just telling us what we're doing to this function of f. That just does these 2 movements right here. Now, what do we have to do? We have to actually apply this to the function of f. So f says take x and square it, and then minus 5 times x. So that's what we're going to have to do. So we're going to take, in this right here, x minus 3. We're going to take x minus 3 and we're going to plug it in and square it. So we're going to have x minus 3 squared. And then we're going to do minus 5 times x. What is x? X minus 3. And then we have to bring down our plus 2 because that's part of the transformation. All right, so if we simplify this, then that takes care of this first step here. 3 units right and 2 units up. Because we're not working with the parent function, it's a little bit more involved. All right, so remember when you square a binomial, you have to do your FOIL method or distributive properties. So you're going to have your inside middle terms are going to be in there too. Don't just square the first term and the last term. All right, so let's square this. We're going to have x squared. Our 2 middle terms would be negative 3x and negative 3x, which is negative 6x. And then negative 3 squared is plus 9. Any number squared is going to be positive. Then we have to distribute the negative 5, so negative 5x. Negative 5 times negative 3 is plus 15. And then again, bring down your plus 2. All right, simplify further. We're going to bring down our x squared. We have negative 6 and negative 5, so we have negative 11x. And then we have 9 and 15 is 24, 25, 26. All right, so this we're calling h of x. And that is what f of x is if we translate it 3 units right and 2 units up. All right, now it says followed by a reflection of the y-axis. So now we have to do something else. So g of x is going to be the function we just looked at, which we called h, and to have a reflection across the y-axis, that means the negative is inside your parentheses. All right. Now, how do we do that? We simply take our equation that we just created right here, and we're going to make everything here for a negative x. So we're going to say this equals negative x squared, because we're just filling it in right here. And then we've got negative 11 times x, but now our x is negative x. And then plus 26. So what we're doing is substituting this value in now to this function. All right, so it's just a process. All right, if I do that, negative x squared becomes x squared, because negative 1 squared would be a positive, and x squared would just be x squared. So that becomes x squared. Then I have negative 11 times negative x becomes plus 11x. 2 negatives when you multiply becomes a positive, and then plus 26. So this would actually be our g of x. So in order to get these correct, you have to think about what each piece does to the function. Plug that in, and then just simplify, and that will get you to your new function. Not hard, just several steps, something that you have to think through and process, and hopefully it won't be too hard.